So a couple of things on our torch here that we've got. We've got two tanks that are going to be set up, and I may have shown you these already before, but this one right here is our oxygen. I don't think you guys can kind of see this right here, but this thing says oxygen. The green bottle is an indication that it is oxygen. So they paint them all the same color. If it's oxygen, it's going to be green. It's going to have labels here. It's actually going to have stamps on the outside of it that's going to indicate what it is. This one right here is going to be acetylene. I think this one might be on the back side somewhere. I think it's buried under, yeah. It's kind of on this back side, but it tells us that it's acetylene. And what acetylene is basically a fuel that's going to be able to catch on fire. Now, this little thing right here is kind of like a bomb. And I know I've told you that this acetylene explodes under 30 PSI of pressure. It will spontaneously combust under that. And so it's something that we have to kind of take caution with, but it doesn't mean that it's unsafe. Okay? But we like to go through, we like to understand all the safety aspects to it, what we need to do, how we need to set these things up. Some of it set up it has to do with how well the quality of work is going to turn out, and some of it has to do with safety. So the first thing that we're going to kind of do is I'm just going to unwrap my hose from around here so that way I've got some working length here to work with. And we have to change out our tip that we have here. This tip is sometimes referred to as a heating tip or a rosebud. These things will actually, if we want to just heat up metal really quickly, it's going to put out a lot of acetylene and oxygen. It's going to give us a flame that's going to be really hot, and it's going to be able to not really melt things, but if we want to bend something, we want to aid in bending, this thing is going to heat that stuff up to be able to get that right. So on this torch body that we have here, we've got our little rosebud tip, and there's a little nut right here. That nut needs to be loosened up. And with these tips, every one of these tips, whether we're working with the welding tip, whether we're working with this little torch body right here, and we have a heating tip or we have a cutting tip on there, there is no wrenches that we put on these things at all. All we should be able to do is just spin this with our hands. Okay, so we don't ever wrench these things down. Where we have, hold it off. Oh. On our tanks right here, right there on our acetylene tank, those ones we actually will tighten those things down. All the hose fittings, those ones are tightened down. Okay, we tighten those things with a wrench. We don't want those to be loose. We don't want stuff coming out. Those fittings actually compress against each other, and that's what seals, and that's why we need a wrench. On this one, and you can see this little tip right here, there's a little O-ring on the inside of this. And our welding tips, our cutting tips, the heating tips here, they're all the same design. They all have that O-ring. That O-ring is going to seal and keep that stuff from leaking out. So these things are all going to be hand tight. You notice I didn't use a tool on there. I didn't have to adjust anything. We're going to take our cutting tip that we have right here, and this thing's got that same little fitting there. Again, it's got a little O-ring. It's got a little O-ring right here that's going to help that thing seal. How we set this thing up just kind of depends on personal preference. I like to personally put this little lever right here in line with these two. But you could theoretically turn it to the side that way. You could turn it to the side that way. You could have it upside down. It's completely up to you. My personal preference is to go kind of right in the middle. So all we're really looking to do is just kind of snug that with our hands there. We will know if we have some stuff leaking out, because we are probably going to smell it. We may hear it, but that thing's just kind of snug. I'm not trying to like tighten it down real tight. I'm not putting a wrench to it. Okay, and I think that thing's going to be pretty tight, and we're going to be good to go. To set up this machine, one of the first things we need to do is we need to get our pressures on. So this oxygen tank here, this is what we consider a high pressure tank. These tanks seal at the base and they seal at the top. So what we're going to do is we're going to open this valve up until we can't open it anymore. And to open it, we go counterclockwise. This valve is now opened. You might have noticed that that gauge went up when I did that. This gauge did nothing. This one is our tank pressure. So this tells us how much gas we have on the inside. And this one is our hose pressure, this hose that runs down here. Now, you'll notice the oxygen hose, right? Just like the tank is painted green, the oxygen hose is green. That is a standardized thing in the industry where all the oxygen hoses are going to have, all the green hoses are going to be the oxygen. Okay, that helps make sure that we don't take this one and mix it up with this one here. The other thing that's on these is that those oxygen hoses are what we call right-handed threads, meaning if you've ever heard the term righty-lefty, righty-tighty, lefty-loosey, that's what these ones are. So from this valve stem that this regulator plugs into the tank, to all these hose fittings, all the way down to here, those things are all going to go right-hand threads to tighten them up, okay? Now, we're going to mess with the oxygen pressure in a second, but what we're going to do is we're going to jump down to our acetylene hose. We're going to do the same thing. We're going to take this tank and we're going to open it up, except on this one, it's no more than one full turn. Well, it's typically about half a turn, quarter to half, no more than one full turn, okay? And you are going to get tested on that, okay? And there's going to be multiple choice. It's going to be pretty obvious. I'm not going to say a quarter, a half, and one full turn. I'm not going to put all those options in. I'm going to put one. I'm going to say it's a half a turn. I'm going to say that's a 2 turns or halfway or all the way. Just pick the one that's there. So typically a quarter to a half. If I were to crack this thing and I turn this a quarter of a way, you notice sometimes this gauge doesn't go up. So what I'm going to do is I'm going to kind of kick it up a little bit more, and now it kind of kicked up. It may be hard for you guys to see that, but that gauge kicked up a little bit. We're almost out of acetylene on this tank here. It's almost time for us to replace it, but we should have enough for what we're going to do today. So sometimes what happens on this is if you kind of open it, it doesn't actually open that valve up, or it may open it, and then it just lets a little bit by, and then as you start working, that pressure will drain down, and we have to kind of open this thing up a little more. So that's why we say it's a quarter to a half a turn, but it's never more than one full turn. And you want to be able to do this and shut this thing off with one quick flick of your wrist, okay? So that's why we say kind of a quarter to a half, because that's going to allow us to shut this tank off. Unlike this one, okay, we want to be able to shut this one off quickly, okay? This one is our flame. If we have a flame that's coming from where that regulator's at, we want to be able to shut this off. And I have seen that happen when I was teaching in Tulare. We actually had a flame that was coming out of the acetylene tank. All we did was walk over, shut that tank off. Once that acetylene burns off, the flame ceases to exist, and then we can tighten everything up and shut. So we've opened up our valves. Okay, the next thing that we need to do is we need to get this gauge to kind of go up on these things. Okay? This one's actually already up, probably because maybe somebody didn't mess with it and they didn't do it right. But on this one, we'll readjust that. But on this oxygen hose right here, we've got these little levers just like the acetylene. Okay, and what we can do is we can turn this knob clockwise to increase our pressure, or counterclockwise to back it off and decrease our pressure. The important thing with this torch is that we do that with those things open. Okay, so on this cutting torch, we have our green, which is our oxygen. We don't have to try to follow those lines. That's why we color code these things. And what we want to do is on this valve right here, counterclockwise to open it up, we want it opened all the way. And then we're really going to adjust our pressure with our oxygen right here. So what we can do is kind of crack this one open. Not really anything coming out. We're going to adjust this valve up. And you can see that that gauge is now up. Hopefully we can see that there. So this one right here, that's our hose pressure. If you read these things on the inside number where the reds are at, that's going to be PSI. You can see 50 PSI. Right now, we're probably about 25. What we're looking at doing on this stuff is we want to get about 20 PSI when we're cutting. We're going to cut some 1/4 inch thick metal. You can adjust that PSI up and down really as much as you want. The thicker the metal, the more PSI that we're going to have on those things. But 20 PSI seems to be pretty good for most of the cutting that we do. It's a good versatile number that works for some thinner metal, works for some thicker metal. But understand that you have that flexibility. But 20 is typically where we like to set those things at. So what we're going to do is we're going to open up this valve. And we have to do this while it's working. And so what we can do is back this thing off, and that lever will drop. We can increase, and that lever is going to increase. If I just increase this thing right here, that's going to go up. And if I try to decrease it, nothing's going to happen because nothing is being let out. So our working pressure is with that stuff actually open. We're going to set that to 20 PSI, and then we're going to close this valve back down. Now I have nothing flowing again. Everything is now stopped. We're going to do the same thing with our acetylene. We're going to take our acetylene valve. This one is not left-handed threads. I didn't tell you guys this. This one, the oxygen one, is a left-hand or is right-handed threads. The acetylene are left-handed threads. That means to tighten it, it has to go to the left. What that does is that prevents these things from being flopped and us accidentally putting the wrong hose in the wrong part. The other thing that you'll notice on this acetylene hose, can you see these notches that are right there? Those notches are an indication that they are left-handed threads. And all up and down that hose, there's notches right here. There's notches up there. There's notches there. And there's notches right here where it goes in to that tank there. So all of those notches are going to indicate that they're left-handed threads. Okay. Red is always going to be for our acetylene. Sometimes with the oxy fuel systems, you might hear it oxy fuel, you might hear oxyacetylene. In this case, we're kind of using those terms interchangeably with each other. But we can use like a natural gas, we can use a propane gas, and it's really not going to change the type of hose that we need. But most shops, most places, acetylene is what's used because that's what's cheap. So we crack our acetylene, and I would have you, normally I'd take this thing and I'd whiff it up into your face, and you would smell it, and this stuff stinks. Okay? They put some stuff in the acetylene to make this stuff stink. So that way, if you smell that, you're going to do that. I would encourage you that if you're in a shop, or maybe if you guys come by to, do your little, plasma stuff, I might have you smell this so that way you know what it smells like. Because if you're ever in a shop, whether you're a shop teacher or not, and you smell that smell, somebody left an acetylene tank on and you're letting flammable gas in that shop. So on this, when we're cutting, we want this to be at 5 PSI. So we open up that valve, we set it to 5 PSI while it's running, and then we set those things up. You may notice, if I bring you over to here, on this hose pressure right here, you'll notice how the 0 is going to be down here. And as we climb up, right, we might be a little bit above the 5 right now. But as we open up this valve, I'm going to open it. See how it kind of drops a little bit? Kind of kicks up, and it kind of drops a little bit. That happens because it builds up a little bit of pressure, but it's our working pressure. So it's with those valves open, what is our pressure on these things? Sometimes they kick up a little bit. As long as it doesn't get into that red area, okay, which is 15 PSI, we never want to go above 15 PSI, then we're going to be good to go, okay? Typically though, when we're doing any kind of cutting, 5 PSI is what we want. If you have thicker metal and you're trying to cut some real thick stuff, you may increase that quite a bit. But again, for any of the things that we do here, and any of the things that we're kind of doing inside of our, high school shops and stuff like that, 5 PSI on our acetylene when we're cutting, and about 20 PSI on our oxygen is going to give us kind of what we need to work with. So now that we've got all of that stuff set up, we've got our tanks on, we've got our pressure set, we're pretty much good to actually start setting this stuff up and start doing some cutting. So what I'm going to do is I'm going to get some gear on. I'm going to move you guys over here to my little welding station. And, put the camera around. All right. Now you'll notice on this thing that there is a bunch of holes. This is just a little table that we have that we cut on. And we just make little cuts. We do circle cuts. We try to fit pipes in there. We try to do all that kind of stuff. We'll move these things out of the way. I'm gonna put my sleeves on. This stuff will throw sparks. So it's important that you make sure that you have all the coverage and stuff like you do with welding. One difference with this, you can use a welding helmet. You just have to use it on the grind mode. This is the welding helmet that we're going to be using. And where are my glasses at? I have no idea what I did. So these glasses right here, let me see if I can shine the light through them here. You can see how they're kind of like a green tint. These are a shade 5 lens. So they're not as dark as the welding glasses, or sorry, as the welding helmets that we have. But they're gonna help protect our eyes because this stuff is going to be kind of bright. So we're gonna move you guys. So these glasses right here are cutting glasses. That's what I'm going to have on while we're cutting. We've obviously got gloves that we're going to work with. And then we've got our welding tip. That's right here. Cutting tip, not welding. Let's see if I can get this thing to focus in on. Come on. Can you guys hear me okay? I got my welding jacket on.
Yeah, we can.
Oh, that's not gonna work. Come on, camera. Okay. On this welding tip, come on, focus. You'll notice there is, if I can hold this thing steady, you can see how there's small, kind of 6 small circles on the outside, and there's 1 circle that's on the inside there that's a little bit larger. Can you guys see that okay?
Yeah, I can see it.
So those 6 circles that are on the outside are what we call our pre-jet or preheat holes. What those things do is those things are going to actually heat this metal up and get it up to melting temperature. And then that center one is actually going to blow that molten material out of the way when we weld. So there's a couple things when we set these torches up that we're going to want to do. If I can kind of get you guys back over here, we'll kind of raise you back up. So what we're going to do on here is we're going to take our acetylene and we're going to kind of just crack that thing open. I'll get my glasses on here and my gloves. I've got a striker right here. We never want to do this with a lighter. We do it with these strikers. You can see some of those sparks that come with these strikers right here. And what's going to happen is we're going to take our acetylene. We're going to crack this valve open just slightly. What we want to do is just have a little flame like that. Here's what you don't want to do. You don't want to take this valve and then open up real big and then have a big old flame like that, okay? You can catch somebody on fire. That's not what we're looking for. So what we're going to do is we're going to crack our acetylene valve. We're going to strike this with a striker. Notice how it's a real small flame. And then what we're going to do is we're going to open up our acetylene valve, going counterclockwise until you see this flame kind of start to kind of feather. I don't know if you guys can see this, but look at, if I go put this on this metal, do you see that black soot that's getting on there? It's on this metal right here. That's unburnt carbons that are on the inside. What we want to do is we want to increase this flame just until this flame kind of starts to feather out. You can kind of see how it's starting to kind of do that. We don't really have, well, we have a little bit of there. We don't really have a lot of that smoke kind of coming up right here. You do end up with a lot of those we'll kind of kick this thing down. I don't know if the camera's going to pick that up. There's a lot of soot that's on the inside right there. So what we want to do is kick this thing up until that flame starts to kind of feather out, kind of like we have right there. And then our oxygen valve, which is on this side right here, we're going to increase this thing a little bit. This is where it's going to get real bright, but this camera should kind of pick this up. We're going to increase this a little bit. And what we're looking for is to set a neutral flame. Okay, can you guys see this okay? Can you see the flame?
Yes.
All right, cool. So what we're going to do is we're going to increase this oxygen. And what we're trying to get is a neutral flame. So I'm going to increase this. You notice how it's starting to become clear? Notice those cones that are on the inside there. There should be 6 of those. Those are those pre-jet or preheat jets that are on the outside. What we're looking for, if you can kind of want to bring this thing out a little bit, I'm closing this oxygen valve. See how it's just like one long cone? And if I start to bring this stuff in, see how they become really crystal clear? Let me know if you can see that. Yeah? See right there at that tip? That's what we want those things to be clear. Now, when we're cutting, we're actually going to hold this lever down. And that's when we get ready to cut, once that metal gets hot, we're going to push that lever down. And that's just going to actually take that center hole, our cutting hole. And that's what's going to push extra oxygen through and force that molten metal out. Now, watch what happens when I hit this valve. you see how those preheat jets get really kind of fuzzy again? That's because the balance isn't right. We do not have a neutral flame. So what we want to do is hold this lever down and adjust our oxygen up until it becomes crystal clear again. Right now, we have what we consider a neutral flame. If these things were backed off and it was like this is an a carburizing flame, which we have too much carbon. That's where we're getting our acetylene from. And if we have it like this, I don't know if you can hear that noise. Okay. This is an oxidizing flame. We got too much. Okay. We don't want as much. We want these things, right, where they're fuzzy. We want to get them to where they're really clear. We're going to hit down that lever and we're going to adjust it until they're clear again. That right there is a neutral flame. This is really the same process that we're going to do on our oxy-fuel welding. Setting up a neutral flame is the biggest thing that you can do when you're oxy-fuel welding. If you set it up right, you're going to give yourself some success. All right, so we're going to go ahead and we're going to start kind of cutting some stuff. And I don't know what I'm going to do. I'm probably just going to cut like a 4-inch piece. I'm going to use my hand as a brace. I'm going to start on the edge of this metal right here. And what I'm looking for is for this metal to kind of start turning a molten color. I'm not pivoting this lever down right now. Once this metal gets to a molten kind of state, and you'll kind of see it because it's going to be kind of a bright yellow color, I can hit this lever down. If I hit this lever down and nothing happens, nothing's cutting, then you just let it heat up a little bit more. Notice now it's ready. We're going to make that cut. We're going to drag this thing kind of across. What you're looking for is those preheat jets. Mess that up a little bit. You're looking for those preheat jets to be about 1/8 of an inch above the metal. You want all that stuff to kind of come across. Your speed is going to be critical. If you go too slow, it'll melt stuff back together. If you do it right, you can notice how that thing just kind of fell off. Basically, that's it. We cut that metal. Obviously, that metal's going to be hot. We can do holes. We can do straight lines. We can do rule of 45s. You can do a lot. This is still used quite a bit in the industry to get things kind of cut, to get things prepped, and then we typically are going to go through and we're going to weld them together. We may have to do some grinding on these things, but the better fit up we do with this stuff, the less grinding and the quicker we're going to be able to get stuff welded together. I'm really not going to get into the cutting portion of it right now. I just wanted to kind of show you that. I'll do a demonstration. I'll do a lab where we, talk about how we cut holes and circles, squares, different things like that. So what we're going to do right now is we're just going to shut this thing down. To do that, we're going to shut our oxygen off. We're going to shut our acetylene off. And that stuff is basically done. When we are done with this, what we want to do is we want to take this and we're going to go in kind of the reverse order that we did before. Not kind of, it is the reverse order. So what we're going to do, that's sort of the right, yeah, I guess it's sort of, it's not exactly. So we've shut those things off. There's no acetylene, there's no oxygen flowing. At this point, when we're done with this equipment to shut this down, we're going to shut off our tanks. We're going to shut off our acetylene. We can shut off our oxygen. We can hit this little lever right here. You can hear that oxygen coming out. Once that oxygen is drained, we can look at this oxygen tank pressure there. If it's all the way down, we're good to go. The tank and the hose line or the working pressure should be down to 0. Once that's clear, we can open up our acetylene. We can do the same thing. Those things are now down to 0. We can shut this acetylene off. And then the last step is to back these regulators off. Go counterclockwise a couple of turns. That's going to make sure that the next person that comes into here doesn't have pressure shooting up on them. Never tighten these things down, these regulators, never tighten them down all the way. That is a bad thing. You can cause issues, you can cause an explosion, especially if it's on the acetylene, and that's not good. That's not what we're looking for. One thing that we do have, and I do want to show you, we have these little things called tip cleaners. Sometimes we get molten metal into the tip of these things. If we do, we take these tip cleaners, we find the right size. We can essentially just kind of file it out, although we're not trying to widen these holes. We're trying to just kind of clear any debris that maybe gets on the inside of them. But there are tip cleaners that we can use that are going to go on the inside. They are just really like mini files that are going to file this stuff out of the way. You may see this when we get into the welding side of things. We may see that we need some of that. So questions with cutting, setting up the machine? Did I miss anything that we needed to talk about? No? All right.
I don't know if you talked about it, but it says, how did we set up the cart for the oxyfuel cutting?
That's what we just did right now. So turning on the tanks, adjusting the hose line, right? So that's everything that we did right now. This is a welding cart, right? So we have wheels, we can move these things around. They're really nice to be able to get to different spots. You done already?
No.
Am I too loud? Okay. Sorry, Mr. Williams came in. He's got his small engines lab going on right now. Okay, so yeah, that's the welding cart. We can weld, we can also cut. Typically out here, we just have these set up as cutting. And then what we have right here is our manifold systems. This is our welding stations. So we've got like 12 welding stations on these things. They're all really identical to each other, but instead of having just one set of tanks running one torch, we actually have, a couple tanks that are running a couple torches. And so this one's going to be a little bit different in how we set these things up, but we'll go through it. There's some similarities. On this, we have 2 oxygen tanks. That's just to provide us with enough oxygen. Same process as before. It's all the way. So we're going to open these up all the way. And awesome. This is good. Notice my hose or my tank pressure. It didn't go up. That's not good, because that means I don't have any oxygen. I'm not going to be able to show you this stuff. So that's going to be good. Anyway, we'll show you what we can. I may not be able to do a demonstration, but we can get to that next week. We can show you that. So we do that. We'd open up those oxygen tanks. We'll open up the acetylene as well. Again, on the acetylene, we only set those things up to a quarter to half a turn, but we turn both of these things on. And that has to do with how much pressure we're going to draw. If that's just me welding, we're not going to draw a whole lot. But if it's somebody else, we've got, a full set of, 12 people welding on there, we're going to be taking a lot of acetylene out. And if we draw it off too quickly, these things could explode. With 2 of them, we're never going to have that issue at all. When we set up the pressures here, on this manifold system, what we would do is we would set this pressure up, and we're not going to go to the 20. We may go up to 25 or 30. And at each station, you're going to be able to adjust those things individually. So on the manifold, we adjust it real high because this thing has to feed all of those lines. We have a main valve right here that can open up and allow that down that line to the rest of those stations. And it's the same thing with our acetylene. And you'll notice our acetylene right here. Notice how we're at like, I don't know, 11 or 12. That might be that might be a little bit higher. It might be getting close to that 15. But with the system, if we run this thing at 5 like we did before, and we're running 12 stations, 12 people drawing off of 5 PSI, none of you are going to be able to maintain a 5 PSI on your tank. So we actually increase the pressure on this manifold system right here. Same kind of thing, adjusting that lever in is going to increase it, pulling it back is going to decrease it. We've got a main shutoff valve right here that will shut off the rest of those lines there. And then we're going to be good to go. So as far as that stuff goes, there are some differences, but essentially it's kind of the same thing on this manifold. Now, unfortunately, because we don't have oxygen, we're not going to be able to weld. But what I can do is kind of show you the same, I can show you the process and the equipment that we have that goes along with this. So set you guys up here. Okay. So it doesn't matter which one of these that we use. What we've got here is we've got our acetylene. We've got a main valve right here that we would open up that main valve. Okay. We have our torch that's right here. We have our welding tip, same kind of thing. These things, there's a rubber O-ring, so they seal just hand tight. That's all you got to do with these. How you orient this is kind of up to you in comparison to where these things are at. I prefer it kind of set up like that. That's just me. Hand tight right there. And then what we do is we open up our acetylene again, just like we did before. And now you'll notice that gauge, see how it kind of jumps up, and I've got acetylene flowing out right now. If I were to back this regulator off, notice how it doesn't really move until I open this and then it drops. Okay, so I can tighten this thing back up, I can adjust it. And when we're welding, we want to have 5 PSI. There's a good example of this thing kind of jumps. See how this acetylene is on, and I turn it off, see how it kicks up a little bit, not a big deal. Our working pressure is 5, that's what we want. So it's the same working pressure on welding as it is with cutting. On welding with our oxygen, okay, it's the same process, just with the acetylene, same exact process. I don't have any oxygen in here because my tanks are completely empty. But on these ones, we're working on this little hose right here. We would adjust this. Typically, we go 5 to 10 PSI when we're welding, okay? Some of these ones, we may not be able to get down to 5. May be kind of hard, so it's really kind of low. 10 is kind of right there. So that's why we say kind of 5 to 10. We don't really want to go 20. It's going to be quite a bit more, and it's going to take a little bit more out of this system. Let me think for a real ride. Okay, so unfortunately, because I don't have oxygen, it's going to take too long for us to kind of get those things out. There's a couple things with these tips. One, the size of this hole, okay, is going to vary from the size of the tip. On this tip, you see there's a 0 there. That 0, we call it an aught. I don't know why we call it an aught. That's just what it's called in oxy-fuel welding. We have aughts, we have double aughts, we have triple aughts, we have 1s, 2s, 3s, 4s, 5, right, 6, 7, 8, 9, 10. Most of the time what we use is an aught, a 1 or a 2, and sometimes we use like a double aught or a triple aught. Now, if you have the numbers there, like 1, 2, 3, the bigger the number, the bigger the hole this is going to be. Chris, can you get me a big tip, maybe like a size 5 tip from inside there? So this one being an aught is going to be a little bit smaller. What the size of that orifice is going to do is going to let less acetylene and oxygen, or more acetylene and oxygen, which is going to burn hotter and melt metal quicker. So if we're trying to weld 2 thin pieces of metal together, and that's typically what we're going to use this oxyacetylene for. If we have a big tip, we can weld a little bit more. We can weld thicker metal. But in here, we typically just weld thin metal. This is all 14 gauge metal or 16 gauge metal. It's all pretty thin stuff, and we're able to kind of manipulate it with it. So this aught tip is going to be pretty good for that. As we get into different joints, and I'm going to show you guys that in the next couple of weeks, but as we get into different joints, it kind of changes things a little bit to where you might need to increase the tip size, and you might go up to a 1. Typically what we do with this thickness, we don't really typically go up to a 2. 1 is really as high as we need to go. Yeah. Yeah. So you can kind of see a comparison. This is a size 3 tip right here in my right hand, and you can see the difference in the size of those holes there, okay? And that difference in that size is going to make a big difference, and this thing is going to be used on thicker metal. You may increase your acetylene pressure on this, okay? You may increase your oxygen pressure because you want more flow coming out. But on this small aught tips, okay, for pretty much everything that you set it up, 5 and 5 on your oxygen and acetylene is kind of what we like to say. Again, that oxygen, you may kick it up to 10, and that's going to be fine. But if you go to 15 or 20 on this stuff, on welding, it's going to be a little bit much. Same kind of thing, except unlike the cutting torch, there is just only 1 orifice. So sometimes those things do get clogged up. The biggest thing with using these tip cleaners, sometimes you'll see this metal, you'll see the flame that comes out. It's just going to be 1 singular flame that comes out. And what's going to happen is it'll like split. And that means there's some debris in there. So you just take this little tip cleaner, kind of go on the inside, kind of clean that off. We've got a little tip file right here that you can clean those things off. So sometimes we have to do that as we decontaminate. These things are pretty old tips. They tend to get damaged if you drop them. It could bend some of this, brass, that this tip or copper that's on the tip right there. It could bend that stuff in. It's going to cause that flame not to be smooth, and you're going to have erratic heating. You're not going to be able to melt metal like you typically would be able to. So, unfortunately, I'm not going to be able to show you that cutting like we said, but that's okay because we're going to see that anyway in the next couple of weeks. To shut these things down, it's the same process. Shut our acetylens off, shut our oxygens off, and then just drain those lines out, okay? When we're done with that, we can back these regulators off, and for extra safety, we can shut these valves down to make sure. But we want to make sure we drain the lines out before we shut these two down. Okay, so we go back to our torch here. We don't mess with these regulators just yet. We just shut our tanks off. We open up our acetylene. Okay, we let that stuff drain out. We're kind of checking our gauge here. We can go back and check our main gauge on the manifold system. But you'll see this thing, once it's there, it's going to start to drop there. Acetylene's still flowing. It's got to take everything out of these lines. Okay, and we don't want to have anything that's left in these lines, because if we leave for the night and we leave acetylene in here, okay, and the fire happens, we have a potential for a big fire to kind of occur here. So that's not what we're looking for. We basically have all our acetylene that's out of this line. We're going to open up our oxygen, even though we don't have any oxygen. We can open it up, just verify that there's no flow. And then if we go back to our main tanks here, you should see that our acetylene is now down. Our oxygen, right, it was already down, never went up. We don't have anything. We can shut these things off because we are done for the day. And we don't want those things to potentially have any leak. If there's a leak somewhere, in here that's going to go in those lines, it can kind of feed those. It's just an easy way of shutting everything off down there. So if some of those valves get left open that are on the table there, it doesn't matter because those little valves are going to shut those things off. So it's kind of security measures to help prevent that stuff from coming through. What questions do you have?
This might be a dumb question, but on the boots there, can there only be like one person, using it, or does it have to be like a multiple person, deal?
No, so you can have one person using that. That's not a problem. Or you can have up to 12 people using it at one time. So it really kind of depends on, how many people are here and how many people are using it, and that kind of stuff. So yeah, one person could do it. We can set those things up. Sometimes, right, draining those lines out is kind of a waste. The difference, there's one difference that I didn't show you, because I did tell you that these tips we can use, like that tip we could swap out, right, the rosebud. The difference between these welding tips on that thing, that tip right here is a lot smaller than that one. And we can't put, so this is like a 200 series Victor torch. This one's a 100 series. There's really kind of two styles. Victor torches are probably the most common ones that you will see. And the systems that we have set up here, they're going to be a little bit small. So I can't just swap out one of these welding tips and put it onto there. They do have bigger welding tips to put onto there, but that's just not what we have here at Fresno State. We kind of have two separate systems. So if I did, I would just put a tip on there and I'd show you guys how to weld. Fortunately, I'll just have to put some more oxygen back into this. All right. What questions did we not answer on this?
I think I missed it, but what tools do you need when changing the tips out?
So you don't need anything when changing the tips out, because it's all hand tight, right? So there's no wrenches. We don't want to take a wrench to it and tighten it down. There's an O-ring on those things. So whether that's the welding tip or whether that's the cutting tip, they're all going to be taken off just by hand. Okay, so no tools are needed. Kind of a trick question.
Okay, I have another question as well.
Okay.
Does it matter if you turn off the oxygen first?
When the flame's up,
Like whenever like you turn it, like when you're setting it up and like turning it off, do you have to do the oxygen first, or can you do like the settling first?
so the only thing that I would say is if you have a flame, what you would want to do is shut your oxygen off and then your settling. Because if you shut your settling off, typically you might get this popping noise. And sometimes what happens is if you have a pop, it could have a backfire where there's a flame traveling back up into that hose. Typically it's not going to happen, but especially if you're shutting off your settling, but it almost has like a backfire kind of approach where you have that settling, and if you got that oxygen, and oxygen just kind of blows that stuff out. And we just try to avoid that as much as possible. So shutting your oxygen off when you have a flame and then shutting your settling off is going to give you a nice cool shut down. As far as shutting the tanks down and bleeding the lines out, so bleeding the lines is when we drain all of that oxygen and all the settling out. That doesn't matter. There's no order on how we do that. Likewise, there's no order on which one we start with. We don't have to start with the oxygen. We don't have to start with the settling. We can turn on one tank and set the hose pressure, and then we turn on the other one and set the hose pressure. There's no real order.
Okay, thank you.
What other questions do we have?
What's the acetylene pressure set to when you're welding again?
It's going to be 5 and 5. 5 on both.
Okay.
We're not looking at the manifold pressure. We're looking at what you're like working with. The manifold pressure is going to be higher because it has to feed the rest of it. When I'm asking that question, I'm asking what are you going to set your individual? Just remember 5 and 5.
Okay.
What else? Did we answer everything?
Basically.
Yeah, we got that. We got all of our stars there. Cool. Yeah, I think we did. Well, if you guys don't have any other questions, then you're free to go. I'll hang around if you guys do have something that you want to ask. Not with everybody. I'm going to go ahead and stop here.